Okay, now we are moving to another very important topic in the chapter of light, that is image formation by spherical mirrors, right? Remember, image, okay, image formation, right? Image formation, image formation by spherical mirrors. What do you understand by image formation by a spherical mirror? That means, in a very simple term, if I am to explain image formation by a spherical mirror, it is actually telling you, if an object, right? If an object, let's say, to explain this, right? Or to understand image formation, let's say I have a concave mirror, right? I have a concave mirror. Now this concave mirror which you see here, right? This concave mirror which you see here, this is the pole, and this is the focus center of curvature. Now let's say if I keep an object behind, right? This is the object. If I am keeping an object here, behind the C over here is center of curvature. Okay. Now if I keep an object behind, so where will the image be formed, right? So if after we finish, right, after we finish this topic of image formation by a spherical mirror, you will be able to locate, right? You will be able to locate where the image is actually formed by the mirror. Right now, as you can see here, the object is behind C, right? The object is behind C. Now where will the image be formed? Whether it will be formed on C, whether it will be formed between C and F, or whether it will be formed at F, or whether it will be formed between F and P, or whether it will be formed behind P. We don't know, right? So this topic of image formation by a spherical mirror will help you, right? Will help you to locate, right? Locate the image. Locate the, or to be very simple, to locate the position of the image, right? To locate the position of the image formed by the mirror. Now, so will this topic help you only to locate the image position of the image? No, it will also help you to find out the nature of the image, right? The nature of the image. What is the nature? I'll tell you, don't worry. It will also help you to find out the size of the image formed, right? The size of the image formed. So after we finish this topic of image formation by a spherical mirror, we will be able to know three things. Number one, we will be able to exactly locate the image, the position of the image formed by the mirror. Number two, we'll be able to know the nature of the image. And number three, we'll be able to know the size of the image. Okay. Now, before we master on this topic, we need to learn about three rules, three basic rules. Please keep in mind, I have told you that this is a very important topic from the exam point of view, because very often they ask one question from this topic for 3 marks in order to draw the image, right? Okay. So as I told you, if you want to master in this topic of image formation by a spherical mirror, the first thing that we need to do is we must know the basic rules. There are three simple rules, and if you know those three rules, absolutely there will be no problem for you to draw the image formation. Okay. Now to explain this, I will take care of what I will make use of a concave mirror. Please keep in mind, whether it is a concave mirror or a convex mirror, the rule remains the same, right? The rule remains the same. So in this case, I'll take the case of a concave mirror, right? Concave mirror. Okay. Now, so this would be the pole, right? This would be the pole. This is the principal axis. Over here we have the principal focus. We have the center of curvature, right? Okay. Rule 1, right? Please understand. Rule 1, right? I hope you can see. Yes, good. Rule number 1. What is rule 1? A ray of light which travels parallel to the principal axis, right? A ray of light which travels parallel to the principal axis So as I was telling, the first rule is a ray of light which travels parallel to the principal axis. Always remember this is the principal axis, okay? So a ray of light which travels to the principal axis after reflection passes through the focus. This is rule 1, right? I hope all of you will be able to remember. This is what? This is rule 1, okay? Rule, this is rule 1. A ray of light which travels this is the principal axis. A ray of light which travels parallel to the principal axis after reflection passes through the focus. Rule 1. Rule 2, right? Once again, let's try to understand rule 2. Okay. Once again, I take a concave mirror. This is the principal axis. This is the pole. This is focus, and this is center of curvature. Now, so rule 1 is a ray of light which travels parallel to the principal axis passes through the focus. What is rule 2? Rule 2 states that a ray of light, okay, a ray of light which passes just opposite, see here, opposite of 1, parallel, focus. Rule 2, a ray of light which passes through the focus, right? Now it is passing through the focus. So we can look at a comparison. It is parallel and passes through the focus. So if it passes through the focus, then becomes what? Parallel. Just see how rule 1 and 2 are mixed in the same thing. Rule 1 is a ray of light which travels parallel to the principal axis and passes through the focus. Rule 2 is just the opposite. A ray of light which passes through the focus becomes parallel. So a ray of light, you can see here, a ray of light which passes through the focus becomes, this is the principal axis, becomes parallel to the principal axis. Once again, a ray of light which passes through the focus becomes parallel to the principal axis. Now this is your rule 2, okay? Rule 2. Then the third one, right? The third one, very simple. Yes, I am telling you, you will have no problem in drawing the ray diagrams if you are able to understand this rule. Rule 3. Rule 3, once again I draw a concave mirror, right? And then principal axis, pole, focus, and center of curvature. See, this is little different. A ray of light which passes through the center of curvature. See, you can see here the ray of light is passing through the center of curvature. After reflection, it will follow the same path back, right? That means the ray of light is coming this way and passing through the center of curvature. After reflection, it will go back the same way. It goes back the same way as it came. A ray of light which passes through the center of curvature follows the same path back. So this is rule 3, okay? This is rule 3. So you have rule 1, you have rule 2, and you have rule 3. So if you can see here, rule 1, once again, these are the 3 basic rules, okay? These are the 3 basic rules that you should know. You should know while drawing, okay? While drawing the image formation, by whether it is a concave mirror or a convex mirror, no issues. The rule remains the same both for concave and convex. So rule 1 is a ray of light which is parallel to the principal axis after reflection passes through the focus. This is the focus here. Second, rule 2. Rule 2 is just opposite of rule 1. Rule 1 is parallel, focus. Rule 2 is a ray of light which passes through the focus becomes parallel to the principal axis. This is the focus. A ray of light which passes through the focus becomes parallel to the principal axis. And rule 3 is a ray of light which travels or which passes through the center of curvature follows the same path back. It comes this way and it also goes the same way back, right? So my dear boys and girls, please remember that if you know these 3 rules, okay, if you know how the rays are moving, it will be very easy for you to draw the position of the image, and by drawing the position of the image you will also be able to find out the nature of the image. I'll tell you what is nature, don't worry. And you will also be able to find out the size of the image, whether the image formed is larger than the object, smaller than the object, is it of the same size as the object. So just say 3 simple rules. will help you to explore the characteristic of image formed by a spherical mirror.